I'm Guy Garcia. I am a software engineering undergrad and the machine vision team leader.
Hi, my name is Alex Espina Santiago. I am a electrical engineer and I'm a member of Rumarino teams in the control division.
My name is Sebastian Maldonado. I'm a third-year computer science engineering student and a part of the software development division of Rumarino. I'm in the autonomous architecture team, and our team's main objective is to join the different codes of the different teams in the software development division into one working system. The software designed to operate the sensors of the submarine will operate as independent modules. One of the most important sensors of the submarine is the Doppler velocity log, also known as the DVL. That will be used to track the submarine position and position of any object found relative to the submarine's position. The information that the DVL will provide will be gathered utilizing the provided driver by the manufacturer. Then, all the processed information from the DVL will be published to the system by utilizing ROS, making it accessible to every module in the system.
Another important sensor is a stereoscopic camera protected by a team-built waterproof housing. The advantage of having a camera with stereoscopic vision is the possibility of determining distance and position from a two-dimensional image.
Finally, there is the AUV pressure sensor that is directly connected to a microcontroller, which sends the incoming data to the AUV main computer.
During the competition, the submarine will have every module working independently from each other, which gives the submarine the ability to make decisions and alter them or react based on sudden changes perceived in the environment to complete the task that it will be performing. The system will always have access to the location information gathered by the DVL and the visual information processed by the camera and other sensors like the pressure, giving the submarine the ability to accurately traverse the course.
Usually, edge computing-based projects are monolithic, which means if the developers don't create an edge case for every possible scenario, the program will most likely fail and halt the system in question. This is why module-based systems are so popular. If developed correctly, when one module fails, it can potentially restart while the rest of the system operates without it. The AI team managed to create a completely independent program for the artificial intelligence module. The visual part is completely disconnected from the rest of the robot. The detection information is posted on a local server that the robot can query to get the visual information. This year's RoboSub competition has some tasks that require the submarine to be able to see and identify objects. Because of the visual obstacles are simple images, an object detection algorithm can be used to find their location on the sub's field of view. Object's location can be determined by the Z stereoscopic camera that we are using for the competition. This locational information is then broadcasted by the server for the rest of the components to use at will.
Embedded devices need to transmit data from one device to another within a system. A two-way communication was established with the AUV mains computer and the microcontroller that is connected to all sensors, actuators, and manipulators, using a framework called Robotic Operating System, ROS. Although this provides a way of sending data from one place to another within our system, this also adds additional overhead because of the many-to-many communication scheme it uses. This is unavoidable for certain sections of the code within the AUV computer, but this can be adjusted for the microcontroller to reduce the overhead caused by this. A lightweight many-to-one scheme was designed to act as an interface between the microcontroller and the ROS-related code in the AUV's computer using Google protocol buffers.
The process of development had many challenges that came due to the current global pandemic of COVID-19. Some of the toughest challenges our teams had to deal with were the restrictions with curfews and limitations of people in gatherings, which made it hard to reunite the members of the teams and to be able to reserve the space and pool to conduct tests in. Also, The delays in the mailing system caused some required two components to arrive at a later date than previously anticipated. Due to these many types of challenges, some of our team efforts were more focused on research and documentation. Some of the research that was done was in preparation of new components that were being installed in the submarine, like the DVL, for example, while reinforcing the existing documentation.
The vision team was able to build a system on a module-based mindset, meaning that each component runs completely independent from the others. This means that complete changes to a module can happen as long as the expected outputs and inputs follow the documentation structure. The module flexibility is accessible through easy-to-modify server configuration files. What makes this flexible system so special is that the visual recognition pipeline can use all the provided modules interchangeably or at the same time. For example, using multiple machine vision algorithms on top of each other. These modules are designed with testing and simulation in mind. It can record past missions with its inference information. This means that if further modifications to either the base code or the machine learning algorithm were to be employed, the testing is as easy as loading up a past mission and comparing its accuracy.
The embedded team designed a programmable testbed to send commands directly to the microcontroller, so the group can focus on testing the sensors and other devices attached to it. The commands in Python are callable objects. So to create the test, one just needs to create a function that uses these objects as a function to communicate and send data to the microcontroller. This let us perform tests for sensor functionality and perform more elaborate tests with other part of the code, like the controllers, by sending a stream of data to a specific command in the microcontroller.